Okay, Bismillah ar-Rahman ar-Rahim. We'll continue doing this 9.5. What we did in this section up to now, we talk about alternating series test, where if we have alternating series, this is alternating series. But if we have alternating series, and we have these two conditions, the limit is equal to 0 or the n term decreasing, then we say the alternating series converge. This is what we did, and we did some example about that. Then we have the alternating series remainder, which is what? If we want to approximate the series by Sn, by the sum up to, up to n terms, capital N terms, then the difference between the total sum minus, I'm talking about convergent alternating series, so it has a sum. So the difference between the total sum and minus the sum up to that n term will be less than or equal a the n plus 1 term next term, which is a capital N plus 1. Yeah, we did also some example about that. Now we'll come to what? Now we'll come to these two ideas, converges absolutely and converges conditionally. What do we mean by absolute convergence? Absolute convergence means when I take the absolute value of the n term, the series converge. Then we say that if the absolute value of the series of absolute value of an converges, then the original series converges. So let me just try to explain that. Now, if I have the absolute converges, then what will happen? Then for sure the original series will converge. So both converges, absolute value and the AN, the original series converges. Now, if the original series, if the absolute value diverges, then we have two cases. If the original series converges, yeah, by the way, you call this absolute convergent. Oops. Absolute convergent. Now, if the absolute value divergent, but the original series converge, then we call this conditionally convergent. Okay, this one they call it absolutely convergent, and that when the absolute value of a and the series of the value of a n converges. If it is divergent, then either the original series converges, conditionally convergent, or the original series diverges, and we say the series divergent. Okay. Yeah. Let me check this one. This series will converge absolutely. Why? Because if I take an assign n over n squared, what I will do with this series? Absolute value, the series of absolute value of an, which is the series of absolute value sine n over n squared. So I have bn, which is absolute value of sine n over n squared. This one is less than or equal 1 over n squared. And this is converges. The summation of 1 over n squared converges. Why? P series would be equal to. So Bn, which is absolute value of an, converges by conversion test. So the AN series converges absolutely. Yeah, say the series. Okay. So instead of checking this, I check the absolute value, and we notice it converges by the conversion test. So the original series, for sure, it will converge absolutely. Which means what? Which means also, yeah, now we have two things. AN and absolute value of AN both are converges. Okay, this one, now, if I take, my AN is this, and my BN is absolute value of AN, which is 1 over N. I know this one diverges. And this one is converges easily. I can check it by alternating series test. Actually, we did it before. So the original series converge, and its absolute value diverges. So that means this series converges conditionally. Okay, so I say the series Bn diverges into the series An converges by, why this is divergence harmonic series. Yeah, very clear harmonic series. Okay. Determine whether which of these series converge or diverge, classify absolutely or conditionally. Okay. Let me take the first one, which is a little bit complicated. Yeah. A. I think I need a space. Yes. A. So my AN will be minus 1 to the power n factorial over 2 to the power n. I want to prove that the limit of AN is n goes to infinity, not equal to 0. Yeah. If that's true, then this is diverges. Then the series, which implies that the series diverges. Okay. How to do that? Yeah. I will take AN is minus 1 to the power, minus 1 to the power n Bn. So I will prove, we will show that the limit of Bn not equal to 0. If that not equal to 0, then for sure minus 1 to the power n times Bn not equal to 0. Yeah. How to check this? So we want to check limit n goes to infinity of n factorial over 2 to the power n, which is limit n goes to infinity 1 times 2 times 3 times 4 times 5 times n, that's the factorial, over 2 times 2 times 2 times 2, n times. Okay. First, I wanted to note this expression. If you put them under each other, over 2. Yeah. If you take this one, Yeah. This one will be greater than 1 times 2 times 3. Here I have 2, 2, 2. And this is 4, 2. 5 will be greater than 4. So I have everything from here, I make it 4. Which for sure this will be greater than, yeah, 5 greater than 4, 6 greater than 4, and so on. 1, 2, 6, yeah, times 4. And this is 2. This is the same. Okay. So that means this is what? This one is what? Is 6 over 8 times 2 to the power n minus 3. So my Bn, which is n factorial over 2 to the power n, greater than 4 over 3 times 2 to the power n minus 3. Okay. That means limit as n goes to infinity, as n goes to infinity, of n factorial over 2 to the power n will be greater than this, greater than the limit as n goes to infinity of 4 over 3 times 2 to the power n minus 3, and that is infinity. So for sure, this limit will be infinity. So that means what? This series diverges. So the series diverges. Okay. I need more space. Okay. Now let me do the second one. This is part B, which is what? B minus 1 to the power n, or to the power over square root of n. An, on the summation of this, starting from 1, yes? Yeah. Starting from 1, n equal to 1 to infinity. An is minus 1 to the power n over square root of n. And Bn, absolute value of An, which is 1 over square root of n. Now for An, converges, summation An converges by alternating series. This y, limit of An, limit of Cn, which is 1 over square root of n equal to 0. And for sure, Cn plus 1, which is 1 over square root n plus 1, is less than 1 over square root of n, which is Cn. So it converges by the alternating series test. This is very clear. But it's positive, everything is clear. Now for Bn, which is absolute value of the summation of An, which is the summation of 1 over square root of n. This is diverges. Why? I know that, yeah, it's a P series with P equal half, less than 1. So this series absolutely divergent, but originally converged, so it's conditionally convergent. Yeah. Okay. Another example. This one. Find my papers. A. Yeah. This is AN. Then BN. This is convergent. So the series converges. Y, geometric with R equal 1/3, less than 1. Okay. So this series absolutely convergent. And yeah, absolutely convergent. B, this one summation, AN is what? 1 over ln n plus 1 minus 1 to the power n over ln n plus 1. This one converges by alternating series test. Yeah. But if I take, let me call it Cn, 1 over ln n plus 1, this is alternating series, yeah. And that I have limit of Cn equal to 0 and Cn plus 1 less than or equal to Cn. Very clear. Actually, less than Cn. Yeah. Add value then. Yeah. Very clear. So it's converged by this. But when we take Bn, which is absolute value of An, that is 1 over ln n plus 1. And so this series will diverge. Why? By comparison test with Tn, let me say, 1 over n, 1 over n plus 1. Since what? Ln of n plus 1 will be less than n plus 1. So 1 over ln n plus 1 less than 1 over n plus 1. And this is diverges. Yeah, this one diverges, very clear. So this series diverges. Yeah. By the comparison test. So this series, this one absolutely convergent, but this one conditionally convergent. Absolutely, I mean, it's originally divergent, but originally converge. Yeah. This one, if you notice, AN, then what will be Bn, which is the absolute value? It is 1 over n square root of n, which is 1 over n to the power 3 over 2. What is this? This is B series with P equal 3 over 2, greater than 1. So the series Bn converges. So this one absolutely converges. this one, if you notice, this is AN. Note limit Cn, let me call it, n over 5, n plus 1 as n goes to infinity. That will be 1 over 5, not equal to 0. So for sure, the limit of AN as AN does not exist. So this series diverges by the interim test for divergence. This is what we did exactly in this case. Yeah, it diverges by the interim test for divergence. Okay. Yeah. I'll come to this one. I have cosine n over n square. Yeah, what I will do, for sure, this is clearly absolutely convergent. Yeah, this is clear, I think so. Yeah, if we take an cosine n over n square, then Bn, absolute value of an, that will be absolute value of cosine n over n squared, which is less than or equal 1 over n squared. But this series convergent, B series, would be equal to, so this series converges by comparison test. That implies this series absolutely convergent. This one, yeah, I think it's very clear. An is this. An is absolute value of an, which is 1 over n squared. This series converges. B series will be equal to. That implies this series absolutely convergent. Okay. The alternating B series. Yeah. What we will do, we notice case A, if B greater than 1, then AN this. That implies Bn absolute value of An. Note this series converges, this Bn, which is the absolute value of An, converges Y converges P series with B greater than 1. Okay, that implies the series for B greater than 1 converges absolutely or absolutely convergent. Okay. Now, second case, if B between 0 and 1, what will happen? Yeah. If I take an minus 1 to the power n minus 1 over n to the power p, then this converges easy to check by alternating series test, since we take say n then the limit of Cn 0 and Cn plus 1 will be less than Cn. Very clear. So it's convergent with kinetic series test, but Cn, which is absolute value of An, which is 1 over n to the power b, this diverges by, yeah, B series with B between 0 and 1. So in the second case, that implies this series An in case B between 0 and 1 converges conditionally, which is this. This is what we get. So that will save our time later. Now we have this topic, rearrangement of series. What's the meaning of that? Now, if I arrange the numbers, shall I get different numbers? So instead of saying 1 plus 3, I will subtract the 2, then I add the 3, and so on. There is a rule. You need to understand this rule. If a series is absolutely convergent, if absolutely convergent, then its terms can be arranged in any order without changing the sum of the series. So any rearrangement of this series will not change the sum of the series. When is that? If a series is absolutely convergent. If a series is conditionally convergent, then its terms can be arranged to give a different sum. And this is an example. Look at this one, minus 1 to the power n plus 1. Okay. Assume I know that it's ln 2. Until now, we don't know how to do that, but this is, assume this is given. This is ln 2, 1. So if I rearrange it, this, I put it on there. Yeah, and also I do the same for, you have 1 minus half. What you will do, I'll take this here, I'll take this, yeah, later with 1 over 10, and so on. Yeah, I do it, which is the same series, but different arrangement. You notice something. I'm getting what? If you continue, if I take this as 1, and this as 1, and this as 1, okay, and continue like that, then I have this, which is what? Which is half minus 1 over 4 plus 1 over 6 minus 1 over 8. Then I can take half as a common factor. What is this? This is my original series. So it's half times ln2. So I do arrangement in a way where I'm getting what? A different sum. Since the series, don't forget, this series is alternating, is the condition, converges conditionally. I know that this is conditionally convergent. I mean, this series converges conditionally. So by doing this trick, I can obtain a sum that is half the original sum. Okay. Now let me go to some old exams questions related to this topic. I'll try to do them quickly. Okay, this series. Look at the question. He gave you the series and he says converges absolutely, converges conditionally, diverges, converges by this test or that test. Okay, this one, yeah. If you take this series, yeah, let me take AN. This one converges Converges by alternating series test. Since the limit of Cn without the minus 1 to the power infinity, minus 1 to the power n, will be very clear, 0, and Cn plus 1 will be less than Cn. Yeah, so it's converges by alternating series. However, if we take the limit as n goes to infinity, not the limit. If we take Vn as absolute value of An, which is 1 over n ln n, then this series will diverge. Why? Why this series will diverge? This diverges. So the series 1 over n ln n diverges. Why is that? I know that ln n is greater than 1. No, not yeah, ln n is greater than 1 for, for n greater than or equal to 3. Okay, so that implies 1 over ln n is less than 1. That implies 1 over n ln n less than 1 over n. And I know that this series diverges. So this series, no, I'm getting nothing. Yeah, that will not help. Yeah, so I need to think about something else. Yes, I'll do the integral test. I think with the integral test, just to remind me about that. So I have f of n is 1 over n ln n. First, f positive and continuous. Yeah, for n greater than 1. Greater than or equal to 2, actually. Yeah. For n greater or equal to 2. And also is decreasing, check. F prime of x will be what? This is 1 over x ln x. Yeah, I will leave it for you to check. Yeah, it will be decreasing. Yeah, let me do it quickly. That will be what? That will be, very clear. Yeah, no need to do that. No need to do the absolute value. I notice 1 over n plus 1 ln n plus 1, which is, call it what? Bn plus 1. For sure, this is less than 1 over n ln n, since you make the denominator bigger. So satisfying this. Then, so satisfy the integral test conditions. Now, if we take the integral from 2 to infinity of 1 over x ln x dx, that will be what? If we take u as ln x, then that will be du. So I have du over u, so it will be ln of ln x from 2 to infinity, which goes to infinity. So this series diverges. So this series converges conditionally. The original series converges with alternating series test, and when you take the absolute value, you will get divergent series converges conditionally. Yeah, this one is a tricky one. You need first to rationalize it, and the rest is just calculation. that will be the series minus 1 to the power n. What I have there, n plus 3 minus n minus 2, which is 1. Yeah. Now I'll work out this. So I have an is this one, which is converges by alternating series test. Y, the limit of Cn, if we take Cn, this one, without, I call it Cn. Equal to 0. And Cn plus 1 will be less than Cn, without equals. Yeah, since the denominator will be bigger. Yeah, very clear. So it converges by alternating series, but Bn, which is absolute value of An, which is what, 1 over square root n plus 3 plus square root n plus 2. This is diverges. Y, take dn, let me call it 1 over square root of n. Find the limit as n goes to infinity of Bn over dn. You have what? I will do the limit conversion test. Limit conversion diverges by limit conversion test. Oops. Okay, that give me what? 1, that be 1, that be n times the reciprocal of that. So I divide by square root of n, or you can do this trick. That take it square root of n. This one, take a square root of n. Then you have 1 plus 3 over n. And this one, do the same. Yeah, so you have what? Where to write it? That will be limit n goes to infinity, square root of n. I can take a square root of n as a common factor. What is the remaining? Yeah, this is goes to I have square root 1 plus 3 over n plus root 1. So this is cancels. So I'm getting half positive. So diverges by the limit conversion test. Which model statement is true? Yeah. Minus 1 to the power n. This is very clear diverges by interim test for divergence. Yeah, the limit does not exist. This one divergent actually, because the limit an is equal to 1, not equal to 0 by the same test. This one, yeah, if you notice, this one is what? This is, if we take n minus 1 factorial over n factorial, this is what? N minus 1 factorial. Well, this one, n times n minus 1 factorial cancels, so it's 1 over n, which is very clear divergent, harmonic series divergence. This one absolutely convergent. This is true. We'll check it later. This one divergent. No, we know this is conditionally, converges conditionally. This one, yes. If we take the absolute value, yeah. How to show this one is convergent. If we take Bn, this is clear conditionally. Convergent, this is wrong. Yeah. So if you look at this one, run D, and to show that this one converges, we take AN, then BN. Okay, I want to show this one converges. Yeah. How to show this is converges. Yeah. It's not difficult one. It is a little bit lengthy one where you need to compare it with 1 over 2 to the power n. Let me just check it. Yeah. Well, you need to compare it with 1 over, yeah, this summation, 1 over n factorial. It is 1 plus 1 over 2 factorial. Yeah. Okay. Yeah. This is 1 plus 1 over 2. And this will be less than 1 plus what, half, half. And this 1 over 2 times 3 will be less than 1 over 2 times 2 plus 1 over 2 times 2 times 2, and so on. Yeah. So I can compare it to 1 over 1 or summation 1 over n factorial will be less than 1 plus summation of what this is half to the power n, where n is starting from 1. Yeah. And this is converge. This one converge. So this one converge. Yeah. So this is absolutely convergent. Okay. This one 1 over square root n plus 1. Yeah, for sure, this is converges conditionally. Okay, this is converges conditionally. Very clear. This one converges by alternating series test. Take Cn. Limit of Cn equals 0. Okay. So converges by alternating series test, but Bn equal this. So this series, which is diverges by, you can do what? Yeah, limit conversion test, limit conversion test with this series. Yeah, this is diverges. B series would be equal half. Yeah, yeah, and the limit will be what? Limit, call it dn, 1 over square root n. So bn over dn as n goes to infinity. Square root of n, 1 over square root n plus 1, reciprocal of the square root of n, where the limit is equal to 1. positive. So it's diverges. So this series diverges by limit comparison test with this one. So converges conditionally. This one, you need to notice that only that cosine n pi is what? Actually, it's minus 1 to the power n. That's it. So this series is the same as this series. And the rest is just nothing. Yeah, at pi equals 0, it will be 1. At pi equal 1, at n equals 0, it will be 1. At n equal 1, it will be cosine pi, which is minus 1. At n equal to 2 pi, cosine 2 pi is 1, and so on. So it's actually this. This is this expression you should know. So and I will leave the detail for you. Converges by alternating series test. I think very clear. Take Cn 1 over n to the power 2 over 3. I think it's very clear. And then Bn, this is diverges P series with B 2 over 3 less than 1. So it's conditional.